Hello learners and welcome back to my channel Bonding with Chemistry. I'm Dr. Seema Singh with whom you're going to study the next topic of first chapter of class 12 chemistry, that is solutions. In the last class we discussed some of the ways of expressing concentration of a solution. We're going to continue with the same topic, and in today's class we'll study one more way of expressing concentration of solutions. So let's get started. So my dear children, let us quickly recap. These were the three ways of expressing concentration that we did in the last video. If in case you missed it out, you can always find it in the description box below as well as in the link on top of this video. Right? So we've done mass percentage, we've done volume percentage and mass by volume percentage. In today's class, we'll pick up parts per million. In the next class, we'll talk about mole fraction. This is one of the most important topic from this chapter because this is going to help you solve numericals of colligative properties. So let's start with our today's topic, that is parts per million. I hope you are writing as well as learning with me. Now parts per million can be abbreviated as ppm. You can write it in short form as ppm. Well, this part per million is used when solute is present in very small quantity. We say that if a solute is present in trace amount, minute amount, that is when we express the concentration of solute in parts per million. Right? So this parts per million is used when you have the component in trace, that is minute or very less amount. The quantity is less, right? And then parts per million, just look at this, parts per million. How many parts of that particular component is present in 1 million of solutions part, right? So 1 million is how much? It is 10 raised to the power of 6. 1 million is equal to your 10 lakhs. So 10 raised to the power 6 constitute your 1 million. Right? So how many parts of a component is present in 1 million part of a solution? That is when we talk about parts per million. So if you look at the formula, we can say, if you have to express in parts per million, is equal to number of parts of a component, it could be solute or solvent of a component, divided by total number of parts of all the components. If it's binary, you have only just two components. If it is more than that, you will have the parts of all the components. Total number of parts of all the components in a solution, right? And we are not taking out percentage, we're talking about in 1 million. So you're supposed to multiply it by 10 raised to the power of 6. That is what is called as ppm way of expressing concentration of a solution, right? Now children, just as we saw in case of percentage, we can express concentration as mass by mass, mass by volume or volume by volume. Similarly, parts per million can also be expressed as mass by mass, volume by volume or mass by volume. What does that mean? Let's see. I just said that if you're having parts per million, you can express it as mass by mass or mass by volume or volume by volume. Let me give you the formulas. For example, you want to express parts per million as mass by mass. So what will happen? This formula you can see here, if in case you're expressing it as mass by mass, right, parts per million as mass by mass, what will happen? You have to write, instead of number of parts, you're supposed to write mass of the component. If it's solute, you're going to write solute divided by total mass of all the components in a solution. So we say total mass of the solution, that means of all the component, multiplied by not 100 but 10 raised to the power of 6. So this becomes mass by mass way of expressing parts per million, right? Similarly, if you have to express parts per million as mass, okay, by volume, what you're going to do? You're supposed to write here mass of the solute. Instead of total mass of the solution, you're supposed to write down total volume of the solution, right? multiplied by 10 raised to the power of 6. Okay, and finally if you have to write ppm as volume by volume, you're going to write down volume of component, let's say volume of the solute is the component there, total volume. So we have total volume of all the components of the solution multiplied by 1 million, that's 10 raised to the power of 6. So what you're supposed to learn from here is what exactly is parts per million, part of the component present in 1 million part of the solution, right? That is ppm. It is basically used for pollutants because pollutant in water or pollutant in atmosphere, they're present in trace amount. So if we have to express the concentration of such pollutants which are present in trace amount, then we talk about ppm, that's parts per million. Let's do some numericals from here which are there in NCERT. So this is a question which is given in your book. They say a liter of seawater weighing 1030 gram has 6 into 10 raised to the power minus 3 gram of dissolved oxygen. That means in water the oxygen that is dissolved, that oxygen is called as dissolved oxygen, which is necessary for the survival of aquatic animals. Express this quantity of dissolved oxygen in ppm. So what we are supposed to do in this numerical, we are supposed to express this quantity of dissolved oxygen. Already it is given that dissolved oxygen is equal to 6 into 10 raised to the power of minus 3 grams. I am supposed to express this quantity in parts per million. I am going to express it like this. Question mark ppm, we are going to find out this question mark. So what is parts per million? They say parts per million is equal to, I'm not writing the formula, you're supposed to write down the formula because you have marks of the various steps when you solve the numericals. So part per million is equal to mass of solute. I'm taking mass of solute as 6 into 10 raised to the power of minus 3 grams. Total mass of all the components is written a liter of seawater. Now the seawater is weighing 1030 gram. So total mass is equal to 1030 gram. I'm supposed to express it in parts per million, so I'm going to multiply it by 10 raised to the power of 6. I'm sure you can simplify and solve this. If in case I have to show the steps, I'm going to write it as 6 into 10 raised to the power of 3, so minus 3 and 6. So divided by 1030. Further simplify it as 6 into 10 raised to the power of 2, 103. And I can also simplify it as 600 by 103. Now once you divide it, you will get your answer as 5.8 parts per million. So you see here that just 5.8 parts of oxygen are present in 10 raised to the power 6 or 1 million part of the solution. Such small amount, trace amount, and therefore we are going to express it as ppm, parts per million, right? Let's take any other NCERT questions from here. Now we do have an NCERT exercise question involving parts per million, right? But I've already written the first part. The second part involves concepts which we are going to study in our subsequent videos, right? So only this much part I'm going to discuss. The question says a sample of drinking water. So you have a sample of drinking water. It was found severely contaminated with chloroform, right? So chloroform acted like a pollutant there, contaminant, okay? Supposed to be a carcinogen. Carcinogen means cancer causing, okay? If something is capable of causing cancer, we call it as carcinogen. So this is cancer causing. So chloroform is supposed to be a carcinogen. The level of contamination was 15 parts per million by mass. So the concept that I told you, that parts per million can be expressed as mass by mass, that concept we are going to use here. So 15 parts per million by mass. Express this in percent by mass. We are supposed to express this in percent by mass. This is parts per million in 1 million. We have to find out how much chloroform is present in 100, let's percent. Okay, let's do step by step, you'll be able to understand. So if I change the color of the ink, take yellow, right? So they say sample of drinking water is having contamination with chloroform. So what is the amount of chloroform? CHCl3 is present as 15 parts per million by mass. By mass means 15 grams of chloroform is present in 10 raised to the power of 6 gram of drinking water. Alright, clear? Now we have to express this in percent by mass. Percent means in 100. So simply unitary method. If 10 raised to the power of 6 gram, 1 second. Alright, we can say if 10 raised to the power of 6 gram of drinking water contains how much gram of chloroform? 15 grams of chloroform. The formula for chloroform is CHCl3. Therefore, can I not find out in 100 grams? I have to calculate in percent. So 100 gram of drinking water will contain how much? 15 by 10 raised to the power of 6 into 100. Right? So let's solve this further. You will have 15 10 raised to the power of 6. This can be written as 10 raised to the power 2. Just simplify this. 15 into 10 raised to the power of minus 4 gram of chloroform. You can leave your answer here, or you can also write it as 0.0015 gram of chloroform. That is your answer. Alright. Now there's a suggestion. I have solved this. You might find this question very simple. But once the class is over, I want you to practice this question without looking at the solution. That's when you're going to develop confidence. Well, with this question, I come to the end of this video. In my next video, I'm going to take up a very important topic, mole fraction. So if in case you have not subscribed to my channel, do please subscribe and also hit the like button. Share this content with learners who you think might benefit. Thanks for watching, and until we meet next, take care and stay bonded, my dear learners.